Hi, this is a Technology RideCast. I'm Marc Farley, and our special guest this afternoon is Dr. Jay Metz. How you doing, Jay?
Hey, how you doing, Mark?
What's interesting is the topic of NVMe, something that's near and dear to you because you're working on it.
I am working on it. I'm spending a lot of time working on NVMe.
You are also on the standards board for...
Yeah, the NVM Express is de facto standards group, and I am on the board for that. It's also the name of the technologies. NVM Express is both the technology and the group that's creating it. So NVM Express is an alternative to SCSI as a storage protocol for a host to access its storage devices, and that storage could be a memory type of system or an NVMe based flash device. It's basically the nature of the relationship between a host CPU and its corresponding memory storage.
Oh, CPU to memory.
Yeah,
okay.
CPU to memory. You wind up eliminating a lot of the abstraction layers that exist in traditional types of storage. So instead of going through adapters, you actually can use the shared memory space of a PCIe connection, for example.
What kind of drivers do you have in NVMe?
Well, there are inbox drivers for all major modern operating systems. There is a difference, however, between a local situation of NVMe Express or NVMe and a remote. So the drivers for a local, which is using PCIe, are all been around for quite a while. The NVMe over fabrics, which is how you do a remote access to an NVMe device, those drivers are in development as of this recording.
So what are the big difference between local and remote? Is it basically timeout values, or?
No, actually, the thing is that with NVMe and PCIe, it relies very heavily on the PCIe transport to have that shared memory space.
Okay.
Right? So it's a memory mapped architecture. The trouble is that once you start doing things remotely, you can't map the memory anymore. So what NVM Express over Fabrics does is it allows you to include transport agnostic delivery systems where you can leverage those kinds of error recovery and still have the efficiencies of a multi-queued system. So the way that the relationship is between a host CPU and its corresponding storage is that you establish queue pairs. Right? You have a sending queue and you have a completion queue. Unlike a SCSI environment, which is an acknowledged response, kind of a situation, you can actually have multiple queues per host connected to multiple different storage devices.
How far up the stack does NVMe access extend to? For instance, is it possible for an application to have its own NVMe queue, or is that restricted to the OS, the container, or something even lower level?
Well, right now the NVMe group is working on extensions into virtual machines and containers so that you can get additional bypassing of these stack systems, right? You have more of a direct connection into the media itself. As of this moment, the applications haven't yet been rewritten to take advantage of multi-queue threading because there was never really any reason from a SCSI-based system.
I would think database systems could really rock with their own dedicated NVMe. I don't know what you call it, stack connector.
Yeah. As a matter of fact, there is a set of APIs that can be connected into from a user space where a couple of vendors in Flash Memory Summit last week have demonstrated that they've done some amazing things with databases accessing a key value cache inside of that liblite NVM inside the kernel space with amazing performance and flexibility.
Yeah, interesting. Yeah, so I'm a storage guy and I like to think about storage. Do you see storage vendors using NVMe between the controllers and the devices inside their subsystems?
Yes, as a matter of fact, we've already seen that there are a couple of vendors out there right now who have an NVMe backend, right? And then they've done a translation to tie into traditional SCSI-based systems in the front end. They've got this enclosed NVMe system that they then present out to hosts, and that's available in the market, has been for a while. But the queuing stops on the back end, so you're kind of getting a hybrid approach of protocols. So if you really want to take advantage of the drivers inside of a host, you really need to be able to do NVMe all the way through.
Hey, so one last area question, and that has to do with instrumentation, metrics, telemetry, and whatnot. Is that anything that's being built into NVMe?
Yes, as a matter of fact, there's a lot of work going on right now. So what the NVMe group is doing is embedding that into the protocol so that you can actually have better communication between the host and a smart target, where you can get better metrics and telemetry data coming back from the devices built into the protocol. So one of the things about software-defined storage as a concept to me is that realistically, and this is my opinion here, not anyone else's, until you actually have the ability for the software to read the information coming from these devices, and that includes in-server storage as well as outside of server storage, then your so-called definition is really just implementation.
We talked about intelligent storage for a long time, and it's always been an oxymoron.
Yeah. I've always found that the words that we use for handling storage has always been kind of problematic. For example, last thing you want to do in storage is be disruptive.
Jay, this was great. Thanks for coming along.
Oh yeah, thanks for driving around San Francisco in the middle of the day.